Relationships between graphs of functions. Describe how, if you know what the graph of y equals f of x looks like, you can immediately draw the graph of y equals the modulus of f of x. Now hopefully you remember from P3 that if we know the graph of y equals f of x, then to get the modulus of f of x, we simply reflect all negative parts or negative outputs about the x-axis. So reflect all negative outputs about the x-axis and leave all the positive ones alone. Leave all positive ones. Okay. And then the graph of y equals f of the modulus of x. Well, if x is bigger than or equal to 0, then f of the modulus of x is just equal to f of x. So everything to the right of the y-axis stays the same. But if x is less than 0, then f of the modulus of x is equal to f of negative x. So, and that's because in that case the modulus of x is equal to negative x. So it just means you do exactly what you did for the graph of y equals f of x on the right hand side of the y-axis, and then you just reflect that about the y-axis, and then that will get you the graph of f of the modulus of x. And then we have a nice little exercise here. Sketch the graphs of y equals the modulus of x minus 2 times x plus 4 divided by x minus 5 times x plus 1, and y equals the modulus of x cubed. Alright, so first of all, I'm going to go ahead and draw the graph of y equals x minus 2 times x plus 4 divided by x minus 5 times x plus 1, so without the modulus signs, and then we'll go ahead and use what we discussed over here to draw the graph, well, to draw the graph of this thing in modulus. Alright, so let's take a look at that now. Wow, goodness me, what a good sketch of the function y equals x minus 2 times x plus 4 divided by x minus 5 times x plus 1. Wow, I think that's the best one I've ever done. I'm just kidding, I cheated and used Desmos. I'm sure you'll forgive me though, because the alternative is watching me stumble around and actually draw it and take like 10 or 15 minutes to do that. So yeah, okay, so this is the graph of the function without the modulus, but we want the modulus of it. Goodness me, that looks terrible. Change it to thin for this part. Okay, now as we discussed, we can, when it's above 0, the graph of the modulus of the function is just the same as the graph of the function. So for all the parts where it is above 0, the modulus function is just going to be the same. So we can go ahead and cover all these parts in blue. I realize I'm not doing the greatest job here, but it's kind of hard to write with this thing. Okay, so that's all the spots where the function remains the same. But, as we can see, we have two parts where the function actually goes below the x-axis. Now in that situation, because we're taking the modulus of the output value, it just becomes positive again. And so we just reflect this about the x-axis. So it's going to look like this. Hopefully you can do it better than me, not so wobbly. And then the same over here. important details, that this thing should be a point. So, I mean, it shouldn't be a smooth curve. So if you've done it as a smooth curve, just be careful. I think this is pointy enough. Same as this situation here. It shouldn't be like a rounded bit here. It should be a pointy bit because it's a sharp reflection. So just be wary of that. And so yeah, this blue one is the graph of y equals the modulus of x minus 2 times x plus 4 divided by x minus 5 times x plus 1. It's just the same as drawing the regular graph, which I think we've done enough examples of so far, and then you just reflect the negative parts. Okay, and this time let's take care of the graph of y equals the modulus of x cubed. Now, we can use the theory we talked about on the previous slide just by looking at f of x equals regular x cubed, and therefore f of the modulus of x is equal to the modulus of x cubed, just in case you weren't clear on how that was related to this. Well, as we discussed before, when x is a positive number, it's just going to be the same as the graph of y equals x cubed. So y equals x cubed looks something like that. And that's equal to the modulus of x cubed for positive values of x, or 0. Okay, and then as we talked about before, if we take negative x and then we put it into the modulus function before we cube it, it's the same as, well, the positive version. And so all that's going to happen is this graph is just going to be reflected about the y-axis. So this one is y equals the modulus of x cubed for x less than 0 on the other side there, which is of course equal to negative x cubed, which is equal to negative of x cubed, because x cubed would continue on like that.